Hello and a very warm welcome to our Data Infrastructure Summit. From wherever it is in the world you're watching, we're sure you'll enjoy today's insightful talks. But this isn't all we offer at AI Accelerator Institute. We also have a number of in-person summits happening too. So whether you want to join us in New York, Los Angeles, or Berlin, we hope to see you in person soon. Lastly, want to learn more? Check out our AI Pro membership, which is jam-packed with cutting-edge AI resources for applied AI professionals, aiming to practice and enhance coding skills consistently. We will be sharing the link throughout the day, or kindly ask our event producer for the full link.
Hello and welcome back, everyone. We are down to our last session. It's certainly not the very least. So I'd love to welcome to the stage, if you could please give a warm welcome to Maher Hanafi, who's the SVP of Engineering at Betterworks. As you can see on the title up on the screen, he's going to be talking us through Stop Building Your Pipeline. So please give him a warm welcome. And yeah, Maher, over to you.
Thank you so much, Albert. Yeah, happy to be here. Very exciting, session today. Hopefully you learn one thing or two. So my presentation will be about, some real use cases, real world scenarios of, building AI pipelines and how, learning lessons from these experiences helped us, stop rebuilding every time and really create consistency and predictability into our AI. So I'm so excited to share notes with you on this and looking forward to help you at least understand, some of these scalable data architecture patterns that helped us navigate AI in production. So, I call this slide the pipeline that looked fine until it didn't. I want to start this by really describing what a lot of teams went through, or maybe going through right now, is when we first saw our first generative AI features. I mean, everything looked great. The feedback was fantastic. Demos looked really awesome. Leadership was excited. Everything was in the green. I would say all the metrics were good. But then, honestly, that was like a little bit overwhelming with excitement. But then, something happened immediately after that, and we started looking at it, and things started failing, I would say, and in an unpredicted and unpredictable way. And the number one thing that failed is the reliability. So we start seeing issues that appeared in ways that were not necessarily easy to track. They were distributed. They were really difficult to debug. Nothing I would call catastrophic, but something that is, for engineers and data engineers and AI engineers, it's not something you would love to see in your implementation, in your pipeline. So that helped us, kind of take a step back and really understand, early on what are the key strategic decisions we need to do and take to really understand, what AI pipeline, data pipeline we're trying to build. First, our initial, strategic bet was that we're not doing any training. Obviously, we are on the applied AI perspective, so we're really focused on inference. How can we optimize for that? How can we build a pipeline that is really inference heavy and focus on that? Second is we tried working with fine-tuning and exploring that early days. There was some, I would say, potential, but nothing that was significantly higher or better than the foundational models that we were using. And honestly, these models kept coming on a very high frequency that every time it was beating the previous models in every possible way. So we dropped fine-tuning as a kind of strategic bet for us. And then the most important thing here is that we were really, like, over time, we understood that we need to invest more in the 90% that is below the waterline. Everything that is part of the infrastructure, the pipeline, observability, guardrails, evaluation, all of these were more important, because over time we realized that the competitive advantage was not necessarily the model itself. It was more, how reliable your system and how mature is your operations, in terms of like achieving deliverable capabilities. That leads to this concept I call reliability, the ability to be able to rely on your infrastructure and really trust it. The first thing that broke was not necessarily quality, was not latency or throughput. It was really how reliable was the system. So before we get into hallucination, latency optimization, we had a very simple problem. How would you make your system consistently complete the request and in a predictable way? We have seen over time a lot of intermittent inference failures. We had timeouts, especially under load. And one of the requirements we had also for launch was the multi-language support. In early days of LLMs, everyone was focused on evaluating English language and all of these things. But because of the nature of the product we had in a SaaS enterprise global customer base, we need to support multi-language. And a lot of things were unpredictably failing and breaking, especially outside of English languages. This is a graph I want to share early on in the presentation, just to capture the journey and how it looked like from an operations perspective. Gray here means success, conventional, I know. Failure is orange. T0, the top graph, shows our failure rate when we started this in our own production, and how noisy and unpredictable it was, especially at load, and how outrageous success rate was low. T1 was after doing some of the optimization pipeline updates I will be talking about today. We had a little bit more stabilized our infrastructure, resolved for some of the bottlenecks, but we still had some areas where we need to look for and improve more. And then at T2, that's where the system became significantly more deterministic. We know we are aiming for the 3 nines and 5 nines in terms of success rate and uptime, and we start seeing that more and more over time. And all this is summarized that reliability improvement are cumulative. The more you do, the more your system will become more kind of excellent at operating and delivering. And it didn't come from one optimization. And also, I would say it's all about removing instability one layer at a time. And we will be walking through some of these layers in a second here. One very important note here is you cannot go and fix everything at once. The order of these executions, these optimizations mattered a lot. And this was one of the early lessons we learned the hard way, because if you start looking at your optimization, you just focus on latency, throughput, and some of the quality of your response while you dismiss success rate and uptime, this could lead to the issues accumulating more and more over time and having to revisit these one after the other. So taking this kind of optimization in sequence, in order, was very important. And the most important aspects early on for us were the success rate, then the uptime, then latency, quality, and throughput. The only way to achieve this at scale was to do it in that order, and skipping some of these steps created technical debt for us that compounded very quickly in our AI system that we had to go back and revisit. With that being said, I want to clarify some of the big aspect of our AI pipeline. It's definitely not an easy one. At Betterworks, as an example, we were going through migration from a monolith to microservices, or I would say from a legacy system to a next-gen system, while at the same time we were building AI. We had explored third-party API-based LLMs as an example, and we, based on the environment we're in, HR tech, SaaS enterprise, multi-tenant, we had to go and build also self-host and self-manage open source models internally. With everything I described earlier, with all the different nuances, I would say most people think that AI infrastructure is just, call an API to an LLM, get the response, and you're good. But in production, it looks more like this. You have many models, you have many databases and different structured data stores. You have retrieval pipelines, you have guardrails, evaluations, you have offline inference, you have roles and permissions to keep in mind, and also you have observability. So the hybrid self-hosted and third-party inference was a good way for us to get really started quickly, but then our focus on reliability and self-hosting led us to improve and optimize more over time. So I would summarize this by saying, but if the AI pipeline and infrastructure is not just a feature, it's a whole ecosystem. You don't have to, you don't design it as, if you don't design it as a platform or as a unified platform early on, you end up rebuilding pieces of the pipeline as you go. And that goes back to the title of the presentation. You don't have to be rebuilding your pipeline if you know what you're doing and if you design it early on well. Now, I want to go through some of the architecture layers that we ended up in really understanding and or identifying as key architecture aspects that we repeatedly needed to across the different features. And each one of these solved a different operational problem. The list here again is, I'm going to focus on these 6, but I'm sure there is more to this, but these are based on real world experiences. The first one was offline inference. in how it reduced our runtime pressure. We will go into every one of these in a second so you can get deeper understanding of this and how they impact your architecture, your data pipeline, your AI pipeline. Batching, in-flight batching in particular for GPU helped us really optimize our GPU utilizations. Guardrails and safeguards being a requirement, not a feature, and how it can protect our user safety, and how it also impacts the other metrics you have, like latency and throughput, and what kind of trade-offs you need to do. Prompt management, as we were trying different models, we are trying different techniques and going from LLMs to agentic, managing our prompts like the same way we manage software with version control and all of that ended up, helping us iterating faster. Evaluation pipelines were very important for us to really control quality and make sure that any little change, no matter how, again, big or small it is controlled and does not introduce questions or, decline quality. RBAC aware, or like really policies and role-based access control aware retrieval was one of these kind of important things to take into consideration, because we have these kind of protected tenant boundaries. We have a lot of things that we have set up and have maturity with in regular cloud distributed systems. But when you add AI, you can introduce leaks to your pipelines, and that's very risky. So individually, none of these sounds like, kind of game changer, but together they become the foundation of what I call a production reliability. So going deeper into the offline inference and why this was considered for us part of our architecture pipeline, data for data and AI, it's honestly one of the highest leverage optimization we ended up finding that is simple enough, but really kind of helped us stop doing the unnecessary work at runtime. And we prioritize offline inference and pre-processing for everything that takes longer time, usually when it comes to inference. And these are things that will jam your GPUs. They will go and sit on the GPUs. There's a long period of pre-filling sometimes because there's a lot of data to ingest. There's a longer sequence of decoding because you're maybe building a generation feature or summarization that takes a lot of inputs and tokens. So we learned that we have a lot of kind of capabilities and use cases that didn't need to be done runtime and can safely be pre-computed, and we did. That's exactly what we did, and we released kind of our GPUs to focus on the other features that were more runtime, real-time data, and we aggressively moved a lot of these kind of predictable inference workloads offline. This helped us optimize our GPU utilizations. We introduced some sort of like cache and validation logics and dramatically reduced synchronous inference traffic. It's one of the most important features and capabilities to consider. Usually, if you use a provider, you can use this at a cheaper cost, batch inference during low time or low usage of GPUs, or if you're building and managing your own pipeline and infrastructure, you can manage to have it either event-driven architecture, driving this, or use and leverage your GPU utilizations to decide when to do it. Next is the in-flight batching and scaling, dynamic scaling, I would say. This was like one of the major unlock we have been using, because GPUs are incredibly efficient when utilized correctly and extremely expensive when they're not. And one of the kind of saying I've seen is like expensive infrastructure. Infrastructure is only expensive if you don't know how to use it. So in-flight batching or dynamic batching in general helped us really treat more and more requests at the same time, group all of these concurrent requests intelligently with advanced inference like VLLM and TensorRT LLMs. You can achieve this and save a lot on your GPU. The other thing that was significant for us when it comes to adapting our infrastructure to load was dynamic scaling strategies. Really understand the different traffic patterns. If you have predictable traffic patterns, nights and days, weekends and weekdays, end of quarter spikes, nightly jobs, and all of that, you should be able to handle a lot of AI traffic proactively and scale your infrastructure to take that into account. So we combined that kind of scaling, which is predictable, pattern-based, with also auto scaling or dynamic scaling, which happens to be, reacting to traffic that was not taken into account in your predictable traffic pattern. One very important thing that we all have to work on is building responsible AI guardrails. At the end of the day, no matter what space you're in, most of the scenarios, if not all of them, require outputs and inputs to be looked at and reviewed. And we have, in the case of HR tech, wherein we have legal and compliance things to align by, and it was very important for us to build these guardrails and safeguards. But as I said earlier, you need to do this without impacting significantly your latency or your throughput. So a few techniques here, and all all of you know that you need to apply safeguards and guardrails to the input and the output. So the only way to do this was to do parallel execution. GPUs are good at that, so you can have the input coming, and you can run your your inference and guardrails check against the input and against the output in parallel instead of doing this in sequence. This will help you with your latency, and you can have checks with different level of risks applying, and then requiring you to react to them in a different way. So all of these helped us manage and navigate the requirements for fast inference while also achieving responsible AI. Number 4, in terms of these kind of architectural layers, I think prompt management was very important. I talked about this a little bit earlier. Because we are focused on inference only and we wanted to be model agnostic, it was very important for us to have these prompts effectively, become part of the product logic and maintain them and version them and really change control them in a very good way. This meant for us that we need to bring the discipline to the prompts and introduce them in a way where we can check for every time whenever there's a change in the prompts and change in the requirements and the inference guidance, we had to treat them as bugs and issues and not just as text files. So that's very important. And the way we also managed its own CI/CD and deployment as part of the infrastructure helped us really move fast and very quickly evaluate models and iterate very quickly. That leads me to this kind of custom evaluation pipeline that was added to our data and AI pipeline. This was probably one of the biggest mindset shifts when we start working on generative AI capabilities, because public benchmarks you see out there are useful indeed, but they are not necessarily, they don't tell the whole story, or sometimes they don't tell you anything about your actual product or how your AI will be used. In the case of Betterworks, we had so many features that most of the models in a benchmark, public benchmark, were having good numbers, good scores, but when applied to our use case, they didn't deliver. So we learned very quickly that average benchmarks doesn't predict user satisfaction in these cases, and we had to build our own evaluation pipeline around our real use cases. These are feature-specific evaluations, production-like databases, and automated in terms of like regression testing, so we know and catch everything as soon as possible. Every little change in your infrastructure, every little change in your prompt can lead to change in the behavior of your AI. So evaluation became a deployment gate for us that could lead to kind of blocking some of the deployment to production just because our evaluation pipeline triggered a concern. And then last but not least, again, I want to highlight some of the examples we have here and how we have been looking at all of these open source models while creating our own benchmarks and see where a new model is better or not at some, and also understanding across the board, not for just one feature, but across the set of features we have. Oops, sorry about that. Going back to the right slide, number 6 in terms of the architecture layers is RBAC-aware retrieval, especially in a multi-tenant system. So this, I think, one of the biggest areas, or one of the most dangerous areas, honestly, is when you try to introduce AI on top of your distributed systems, you might be leaking data because your retrieval is looking at things beyond the control you had in place with your SQL database, as an example. So you have proper filters and queries built in one way, but when you integrate, a RAG system, as an example, it's just looking at a vector DB that doesn't have any of these controls. So early on, it was very important for us to understand the risks of running this without the proper consistent RBAC and how it might lead to leakage of data at many levels, not just at the generation, but it could be, at the document retrieval, it could be at the query intake and all of that. So from a mindset shift also, it was very important for us to make sure that every query, every retrieval we do is taken into consideration the two aspects, mainly the RBAC or policies, whatever you have, controls in place, and also the multi-tenant. One of the worst case scenarios, and we've heard stories early on the generative AI days where some I would say retailers they built an AI chatbot and the customers come in and check, what is the best product you have, and that kind of retailer was promoting products from another competitive retailer, was because they didn't take into consideration filters like this and kind of sort of awareness of what needs to be on the response and what you have the right to. So it's kind of a cornerstone for building proper AI with a proper data pipeline, is how you integrate your controls without also impacting your latency. So any checks you need to do should be quick and fast, should be cached in a way that your AI could respond in the same way your queries to the database or your APIs will work the same way. All that leads to this kind of LLM proxy, or what is known by the AI gateway. So after looking at all of these architecture layers that we have learned through the journey of building AI and building data pipelines for our AI, we ended up realizing that we need an abstraction layer. It's for the entire AI ecosystem. We couldn't build AI as AI product embedded into the software. It had to be an AI unified platform with a proper input and output kind of gateways. This turned into what we called LLM proxy, but like on the market is known as the AI gateway. It centralized mainly the routing, the retries, the batching, how you manage your prompts and all of that. It has also a zero trust, component for identity and access. It has a networking layer to decide where to go from there and what kind of models you have access to, while adding a lot of LLM-based or LLM-aware decisions for how you scale, how you do load balancing, how you route. So some features could be routed to different models. Some requests could be routed to different GPUs based on which GPUs is running what. Maybe you can leverage your KV cache and understand your decoding. If you're running a lot of generation, or kind of question answering, it could go to a very specific set of GPU or GPU cluster. Why? Because you have been doing this, and the KV cache has a lot of that and the decode, from a cache perspective. So all of these different dynamics could be and should be centralized in this kind of AI gateway. The other thing is how you manage your workload. We talked about batching and scheduling and evaluation, all of that. And one of the most important aspects I talked about earlier is AI observability. It's really quite significantly different from just the pure AI API-based services. Observability, you need to be able to look at the metrics differently and monitor them from your token usage, from the GPU usage, and understand the different nuances of how you use that GPU usage, how you leverage the kind of idle time of your GPU, how you squeeze more into batches and all of that. And then from a tracing perspective, as we build more and more agentic workflows and all of that, it's very important to visualize in your pipeline the different steps of your operations when it comes to an AI request. This has been shifting significantly from the days we had an LLM when we make an API call to it, to more and more complex agentic AI with multi-step actions and all of that, and with edge agents and sub-agents. So it's very important to build that kind of visibility into traces. And then again, one of the most important aspects is how we changed our load balancing, or how we need to keep changing our load balancing and our routing and our scaling to be aware with LLM-based signals, not just CPU and memory and maybe number of connections. So this kind of, once you operate multi-model aspect like this across multiple providers, maybe this layer become a little bit more valuable over time. A quick reminder in terms of real case, a real world scenario here. We were doing all of this while also migrating from a legacy system to a next-gen system. So we had to build AI, and we learned that AI could not be built in a vacuum as a product. It had to be a unified platform. So building all of this while maintaining and supporting all of these different clients, I would say, or use cases, was an architecture challenge for us. But definitely with this design, with this kind of perspective of how to build a proper AI pipeline, I think it helped a lot creating that kind of level of consistencies. We couldn't afford to separate the systems and build a legacy AI system with a new AI system. So we had to build a unified, externalized underneath both of them. Same retrieval, same policies enforcement, same observability, all of that, but different inputs and outputs based on the system it's coming from. Trying to kind of summarize some of these things while also introducing one last idea, which is really the importance of production feedback. One of the most important aspects of our architecture is how we can collect feedback from the use cases and continuously improve our evaluation data sets, as an example, our prompts and all of that. So I do believe that the strongest AI systems are not just static systems. They keep evolving. They learn from the operational feedback loops. So it's very important to set up these kind of feedback user experiences and get that into your data pipeline and get that into improving your scores for your own pipeline for evaluation, all of that. And then any prompt updates need to be tracked so you know the feedback is coming against which changes of the prompts and how you manage to navigate that. And then most importantly is how your engagement, how the end user engagement with your product might lead to understanding how good your data pipeline is. Well, summarizing all of this, there's something I talk about a lot, which I call the AI iceberg. Sometimes you go into these kind of architecture discussions and data pipelines and focus on what the end user sees. That's in my opinion just the 10%. The 90% below the waterline is what you need to spend more time on, and how you optimize them and how you build them to achieve that kind of to deal with that operational reality that is hidden to the end user. And the organization that succeeds long term are usually the ones investing below this waterline. Now, final thoughts just for everyone here to take back is, as you are working on these optimization for the pipelines and improvements, think about that sequence. That is very important: the success rate, the uptime, the latency, the throughput, and the quality, and all of that. So really do them in that sort of order, or whatever order you feel comfortable with, as long as it doesn't create, going back and rebuilding and optimizing from scratch. And then take AI security and AI guardrails and safeguards, very seriously, because otherwise you will end up, rebuilding your pipelines to address these later, and these could be very costly in terms of time and resources. And then last but not least, make sure you have your own evaluation pipeline that are built around your product features and use cases, not the public ones. So with that being said, I want to make sure you all have the opportunity to connect with me if you have any follow-up questions. And I hope this was my kind of little kind of a review or insight into how to build AI infrastructure without rebuilding and rebuilding over time. Thank you, everyone. Not sure if there will be a Q&A, or I don't think we have much time, but yeah.
Thanks, Maher. So we've got actually one question from Scott. I'll paste it here actually. So he's just said, do you think too many teams optimize for speed before they've built stable foundations?
Oh, absolutely. Yeah. A very good question and a very real one. Yeah, a lot of teams will just focus on the end user experiences. As I said earlier, you will be looking at the end user performance, the felt experience in terms of latency and the speed of your responses, but they miss what is below the waterline, where is below the iceberg, and that can be, again, very expensive on achieving and addressing and rebuilding, because that's where proof of concepts, I would say, are very exciting and very hyping or overhyped sometimes, because you feel like, oh, it's amazing, it's so fast, it does what I need. But as soon as you're trying to get this into production environment with all the constraints you have, then you start facing these realities. So again, this is where some of these experiences and real world scenarios are helping with understanding the pitfalls ahead of time and design a system that is built from the ground up versus from the top, user experience that you're looking for. Yeah, and frameworks like this could help, understanding some of these challenges and build from initially like a proper AI platform that can serve these great speedy experiences, but also while taking into account all of the other constraints.
Thank you very much. I think we're just out of time, but yeah, thank you very much, Maher. We'll wrap up now. So once again, thank you for joining such an insightful session. For everyone that's tuning in, that's the end of the summit. So thank you for closing us out. All the recordings will be available from tomorrow onwards, so feel free to log back in and rewatch all the videos. But yeah, thanks for joining, and hope to see you all soon. Thank you very much. Bye bye.
Bye.